Assalamu alaikum, students. Can you hear me?
Walaikum salam, yes.
Okay, so today, inshallah, we're going to continue from where we stopped last time. So let's have this numerical. Okay, the 20 Newton bottle rests on the checkout conveyor at a grocery store. If the coefficient of static friction is zero point 0.2, determine the largest acceleration the conveyor can have without causing the bottle to slip or tip. The center of gravity is G, and it is mentioned in the picture. So before moving over towards the solution of the problem, the first thing is that let's try to understand the question statement. So there's a conveyor belt, and over the conveyor belt you have a bottle, and the bottle is 20 Newton, and the conveyor belt is moving. So let's say this is the direction of the conveyor belt motion. Okay, so obviously when the conveyor belt is moving, so if the conveyor belt moves very fast, what will happen? There is a possibility that the bottle slips below, or the conveyor belt slips below the bottle. Okay, so slipping action may occur. Okay, if the conveyor belt moves very fast, so we want to find out what should be the acceleration of the conveyor belt such that the bottle does not slip over this belt. This is one thing. The second thing is that there's another possibility that if the conveyor belt moves very fast, then the bottle might get tipped down. Okay, so bottle might get tipped down. Okay, so we want to find out what should be the velocity of the conveyor belt so that the bottle may not tip. So slipping should not be there and tipping should not be there. Okay, slipping means bottle is standing on its own position while the conveyor belt is moving down. So conveyor belt is moving uh, against the bottle. Okay, and tipping means that the bottle is still moving with the conveyor belt, but the bottle actually tips down. So it becomes the moment is applied across this point because the acceleration is here, so the bottle may get tipped down. So the bottle has the radius 3 centimeter, and the G from the bottom of the bottle is at 16 centimeter. Okay. Before moving over towards the solution of the problem, first, do you understand the problem statement or not? Is the problem statement clear or not? Okay. So let's see the solution. So let's say that for no slip condition, if the bottle does not slip, okay, if there's no slipping of the bottle, that means let's the bottle stays intact. If there's no slipping, the bottle remains intact with the conveyor belt. Let's say this is the conveyor belt. Okay, and since the bottle is not moving against the conveyor belt, so there will be coefficient of static friction which will be acting. There will be coefficient of static friction which will be acting at this location. Okay, so let's try to apply the equilibrium of forces. Okay, so when we apply the equilibrium of forces, okay, so summation fx equals to max. Okay, so in this case, summation fx, so which is the force in the x direction? That will be only one force. Okay, so that will be the force of friction acting. Okay, because since the conveyor belt is moving in this direction, so it will tend the bottle to move in the opposite direction, but the friction force is going to act against the bottle tending motion that will be in this direction. So this direction will be the friction force acting. So F is equals to M because it is given 20 newtons, so 20 by 9.81 into AG. So this equation is going to, this will be equation 1. Okay. Uh, one student asked me, can you please repeat? Oh, sorry, I didn't see. What do you want me to repeat? Explaining the motion. Okay. On the graph. Graph. I mean on the figure there. Uh, okay, here, right? So what we are saying is that suppose if the bottle is there on the conveyor belt, what is asked in the question? What should be the acceleration of the conveyor belt? This is what we need to find. What should be the acceleration of the conveyor belt so that we don't want the bottle to slip? Because if the conveyor belt moves too fast, the bottle would stay in the same position and the conveyor belt will slip. Okay, so we don't want it to happen. We don't want slipping between the bottle and the conveyor belt. Okay, and the other thing is that we also don't want the speed to be such that the bottle tips, goes down. Is it clear? No? Okay. Okay, so we were looking at the problem. Okay, so first, when we take the summation of forces in the x direction, okay, so this becomes our equation for the x direction. In y direction, obviously, there is no motion in the y direction. Okay, the bottle and the conveyor belt is moving in the x direction, but there is no acceleration in the y direction. So ay is 0, so it becomes summation fy equals to 0. And since it is 20 Newton, so the normal force will be actually 20 Newton. N minus 20 will be 0, that N will be 20. Once you know N, you can apply here to find out the force of friction. Force of friction is basically what? Mu s n. The body itself is not moving right now, so we are solving it for the case when the body should not move. If the body does not move, then this force of friction is a coefficient of kinetic friction, coefficient of static friction multiplied by the normal force, and that will be like zero point 0.2 into 20, so it's like 4 Newton. So if we have this thing, we can find out what should be the acceleration. So if the conveyor belt is moving at 1.962 meter per second square, if this is the acceleration of the conveyor belt, still the bottle will not slip. This was the first part for no slip condition. Before moving towards the next part, is this part clear or not?
Doctor, why have
Yes.
you said it's static friction?
It's static friction because the bottle is still on the conveyor belt. I mean, the bottle is moving with the conveyor belt, but not relative to conveyor belt. I mean, do you understand my point here? uh,
Yes, okay.
okay. How did we get ag? How did we get ag? Because this is the equation for ag. Is this equation clear to you? Is Shahad, is this equation clear to you? Yes. Okay. So here in this equation, you have F, which is the friction force. Okay. So first we find N, and once we have N, then we have friction force formula is what? Coefficient of static friction multiplied by N. So this will give us F. So once we have F, just substitute the F here. Okay. Is it clear? Okay. Before moving over to the next step, till this point, is it clear to everybody or not? You can ask the question if it is not clear. Okay. So let's move towards the other point. The other point is that for no tip condition. Now, for no tip condition, now we cannot apply this thing here. Okay, this equation. Why we cannot apply this equation here? Because there are no forces. I mean, there are no forces here because the force of friction will be there when the surface part when the bottom surface of the bottle is in contact with the conveyor belt. But the thing is that now we are saying it's a tipping condition. Okay, suppose if the bottle start tipping, what will happen? The whole bottom of the bottle will be lifted up. Only one point will be in contact. If only one point will be in contact, so this equation becomes invalid. Okay, so we cannot now use this equation for the tipping condition. Okay, so because for the tipping condition you won't have this f here. Okay, because this f will be only at the tip there, not over the entire surface. Okay, so now what we're going to do, okay, summation fy equals to may. Okay, this is going to be exactly the same as before. So the normal force will be 20 newton. Okay, but then what we're going to find, we're going to take the moment at this o, moment at o. Okay, summation of moments at o will be equal to uh, what? So now we have acceleration here. Okay, and uh, overall whatever the forces that we have here is just the force of the weight. Okay, so the force of the weight is going to apply the balancing, it is going to apply the balancing moment. Okay, so this would be in this direction. If we consider this direction as positive, then it will become negative 20 into zero point zero 0.03, because this will be zero point zero 0.03, and this thing is equals to MAD. Because as if you remember, I told you that if a body is not rotating, if the body is not rotating, and we are taking moment at any point other than g, we are not taking the summation of moment at g. If we are more taking summation of moment at any point other than g, then uh, it, summation of moments will not be zero, rather it will be MAD. Okay, so m is the mass, a is the acceleration in this direction, and d will be what? D will be the moment arm here. Okay, so the acceleration will be acting upon we will consider it to be as the center of mass g is moving. So we have to multiply it with 0.16, because it was mentioned in the question that this g is at 16 centimeter from the bottom. So if we use this, if we take the moment at O, so we're going to get the AG, that will be like 1.839. So if the acceleration goes 1.839, okay, if the acceleration goes higher than that, then the body will tip. Okay, so if the acceleration remains below than that, then the body is not going to tip. So is this thing clear or not? Is there anything within the solution which is not clear? Okay. Okay, let's see this problem. The hand cart has a mass of 200 kg and a center of mass at G. A force of 50 Newton is applied to the handle. Neglect the mass of the wheels. Find the normal reaction at each of the two wheels at A and B. So this is the hand cart. Okay, so force is applied 50 Newton at P, which is at 60-degree angle. Okay, and we need to find out what are the normal reactions at each of these wheels. Okay, this is a similar problem. We did this kind of problem two times before in the last lecture. We can go through it quickly. Okay, so we take the summation of the forces in the x direction. It will go equals to max. Okay, so we will have just one component of force in the x direction, which will be in the negative x direction. So it will be p cos 60. So negative 50 cos 60 equals to 200 ag. So we're going to find what is ag. And we can take the summation of forces in the y direction. Then we have na plus nb minus 200 minus 50 sine 60. So this is going to be na plus nb. Now the next thing is that we need to take the moment, summation of moments. So we can take the summation of moment at g, it will be 0. If we take the summation of moment at g, it will be 0. But if we take the summation of moments at a or b, then they will not be 0. Okay, so here we took the summation of moment in my solution and at b. In the lecture slides, the summation of moments were taken at g. So you have two ways of solving the problem. Both are correct. Okay, so if you take there won't be friction force between wheels and the floor. Let's see the problem statement. The problem statement. No, the problem statement does not state anything about the friction, so we have to. Yeah, it should be mentioned as a smooth floor. But suppose if there is no, because for the case of the friction, the coefficient of static or kinetic friction is a must to be provided. Suppose if it is not provided, if it is not even written in the question that it is a smooth surface, but the coefficient of static or kinetic friction is not provided, then you can say that assuming that the floor is smooth, since no coefficient of static or kinetic friction is not provided. So assuming that the floor is smooth, and then you can continue in this way. But anyways, your point is valid. So yes, so you can take the summation of the moments at b equals to MAD or MAH here, as I wrote. Okay, so if you take it at b, then it will be 200 into zero point 0.2, 200 into 9.81 into zero point 0.2, and then we have na into zero point 0.5. That will be negative na into zero point 0.5, and then you have 50 cos 60 and 15 sine 60. Both will have moments at b. So in the end, you're going to get na, and once you have na, you can use this equation to get nb. This was actually a simple problem, a similar type of this problem we did before in the last lecture. So anyways, the problem solution is done here. Anybody want to ask anything, you can ask. Okay, let's move over to the next problem. Okay, we have the 100 kg beam BD. This beam is 100 kg, a very heavy beam. Uh, Shown in the figure is supported by two rods having negligible mass. You know what, these things also confuse a lot. Okay, so this rod AB and this rod CD is actually having negligible mass, and this beam BD is 100 kg. So but in reality, when you see it in the drawing, it looks like that everything should have the same weight. Okay, but but you have to read the question and then imagine that this is something very thin and this is something very, very thick and made up of very heavy material. So anyways, the 100 kg beam BD shown in the figure is supported by two rods having negligible mass. Determine the force developed in each rod if at the instant when theta is 30 degree, omega is 6 radian per second. So this is the case of now in this case AB and CD are the two rods, but these two rods are in the pure rotation. Okay. However, since these two rods are of the same length, so it will cause the beam BD not to rotate, but to move in curvilinear translation. So the beam BD is going to move in a curvilinear translation. Okay, so it will not rotate. It is horizontal, it's going to remain horizontal during the motion. So anyways, this is what we need to find. We need to find the forces. Okay, so force is going to be developed here. Obviously the weight of the beam is acting downward. Okay, but the beam is not going downward because there is force developed in the rod AB and in the rod CD, and these two forces are actually canceling the weight of the beam, so that it's not going down. Okay, it's just rotating or staying connected to these rods. So we need to find what are these forces. Okay, at this instant when theta is 30 degree, omega is 6 radian per second. So this is what we need. We need to find FB and FD. Before moving over to the solution of the problem, do you understand the problem statement or not? Okay, now let's try to go with the solution of the problem. Since we know that the rods are rotating, but the beam will be in curvilinear translation, and we know the motion of the beam. We know the motion of the beam because you can see here the beam is going to move with the rod. The beam is going to move with the rod. If the rod is going through circular motion, if both the rods are going through circular motion, so obviously the beam is also going to go through the circular motion. It's going to be circular motion. Okay, so we know that it's going to be the circular motion. Since we know the motion itself, okay, so we can use the normal and tangential coordinate system. That would be much better to solve the problem. Okay, now let's try to solve the problem using normal tangential coordinate system. If we use this coordinate systems, and then let's analyze the problem here. Okay, so FB and FD would be in the normal direction. Okay, so that will be the normal direction, and since the motion will be like this, since the motion will be like this, so that will be the tangential direction. So this will be T, this will be N. Okay, FB and FD will be acting in the normal direction. Okay, and G will have the tangential direction. Okay, the other thing is that this angle is 30 degree, this angle is 30 degree. Obviously when these two angles are okay, the weight of the beam will be acting vertically downward. Since the weight is acting vertically downward, however, I can draw here parallel lines to n direction and then vertical direction. So this will also be 30 degrees. Since this is 30 degree, that this is 30 degree. Opposite to this will also be 30 degree. Okay, so because we need to find the component of weight in the normal direction and component of weight in the tangential direction, since we are solving in the normal and tangential direction. Okay, so is the figure clear so far? Okay. Okay, so let's see the solution. Um, the Let's say that we take the summation of forces in the normal direction. The summation of forces, summation Fn equals to MAN. Okay, so in the normal direction, what are the forces we have? We have FB, we have FD, and then we have the weight component of weight in the normal direction, but that would be in the opposite direction. So FB plus FD minus 100 into 9.81 cos 30. So that will be cos 30. Okay, this thing is equals to 100 AGN. Okay, so or 100 AN because MAN. Okay, now let's talk about an. An is equals to omega square r. We already know, we for the case of because this is there is rotation here. There's okay. So for the case of rotation, we have an will be equals to omega square r. So omega is given, okay, and r will be the radius here. So it will be 6 square into zero point 0.5, so that will be 18 meter per second square. Okay, so once you have this thing, you just substitute the value of a n here, and so you get fb plus fd. Okay, the other thing is that then we can take the summation of forces in the tangential direction. Summation of forces in the tangential direction will be mat. Okay, so this will be 100 into 9.81 sine 30, because in the tangential fb and fd are both in the normal direction. We will just have a component of weight in the tangential direction, so that will be, the previous one was the weight cos 30, so this one will be weight sine 30. So weight sine 30 equals to 100 into AGT, so we get the tangential component of the acceleration. Okay, still we didn't get FB and FD. Okay, so now we need to take the summation of moments. Okay, summation of moment. Let's say we take the summation of moment at G. If we take the summation of moment at G, this will be equals to 0. Okay, so summation of moment at G will be equals to 0. So here we can take so FB cos 30 multiply by zero point 0.4, and FD cos 30 multiply by zero point 0.4. But these two moments will be opposite to each other. So this will be a moment like this will be a moment like this. So they will be opposite to each other. So anyways, they are going to cancel each other. So so we get FB equals to FD. If we get FB equals to FD, we substitute here. We get FB and FD. This is how the solution of this problem is done. Is there anything within the solution which is not clear? Please ask. Yes. Sorry, I couldn't hear your question. I'm sorry. Are other students able to hear what she's trying to say? Okay. Sorry, we couldn't hear you. The last step. Uh, Here, where we take the summation of moments at G. G is the center of mass. So when we take the summation of moment at G, should be equals to 0, because this is not a rotary motion. This is a curvilinear translation. So for curvilinear translation, there is no moment at G. Summation of moments will be equals to 0 at G. Okay, so here what we're going to do, how do we find the summation of moments at G? Weight is acting at G, so weight will not have any moment at G. But this force, the vertical component of this force will have a moment at G, and the vertical component of this force will also have a moment at G. So vertical component of FB will be FB cos 30, and vertical component of FD will be FD sine cos 30. So FB cos 30 and FD cos 30 will have moments, but these two moments will be in the opposite direction. Okay, so the two moments are actually canceling each other, or causing. If you substitute the values, you're going to get the answer that this thing minus this thing equals to 0, or you can say that FB equals to FD. I don't know. Did you understood what I tried to explain? Anybody else who want to ask anything? Okay. Okay, so now let's solve the case when we have the rotation about the fixed axis. Okay, whenever we have the pin connection, okay, so if G and O, if the center of mass and the center of O, let's say that O is the center of rotation. If the center of mass and center of rotation are same, then we can use the horizontal and vertical component for solution. Okay, otherwise we can use the normal and tangential coordinate system. Okay, and that's it. So let's have this problem. Okay, the pendulum. This is the pendulum, and it consists of a 10 kg uniform slender rod. So this rod is 10 kg. Okay, and a 15 kg sphere. So this is a sphere which is 15 kg. If the pendulum is subjected to a torque of 50 Newton meter, so there is a torque. There's a torque applied over the pendulum. How much it is? It is 50 Newton meter, and has an angular velocity of 3 radian per second. So there is an angular velocity of the pendulum. This is 3 radian per second when theta is 45 degree. This is how the theta is mentioned. It's 45 degree. Determine the magnitude of the reactive force pin O exerts on the pendulum at this instant. Obviously, the pendulum and is made up of rod, and it is made up of a sphere, and they are heavy. They're 10 kg, 15 kg. So they want to go down, but they are being held by this pin connection O. So there will be reactive forces over the pin connection, and we need to find that how much is that reactive force? What is the magnitude of those reactive forces which are acting over the pin connection? Okay, so here we have at a specific instant, this pendulum has there's a torque applied over it. Torque applied over it means there is an externally somebody is trying to produce moment, produce a torque, rotate this pendulum. So externally 50 Newton meter is being applied over the pendulum, and at this moment the pendulum has an angular velocity of 3 radian per second when theta is 45 degree. So we need to determine the magnitude of the reactive force that the pin exerts at where pin O exerts over the pendulum at this instant. Before moving over to the solution of the problem, first of all, do you understand the problem statement or not? You can say yes or you can say no. Okay. Okay, so let's see the problem solution. Okay, so we have the rod, which is 10 kg, sphere 15 kg. The external moment applied is 50 Newton meter. Omega at this instant is 3 radian per second, and theta is 45 degree. Uh, we can apply the normal and tangential coordinate system here in this case, because we know that this pendulum is rotating. It's a pure rotation. Okay, it's moving in a rotatory motion. Okay, so uh, the motion is like this. Since the motion is like this, so we know that this is the tangential direction, and the normal direction should be towards the center of curvature. Okay, so that's the T and N direction. Okay, so now what we do is that we take the summation of forces in the normal direction. Let's say when we take the summation of forces in the normal direction, so summation Fn equals to MAGN. Okay, so here we will have okay, so you'll have normal reaction at On will be there. This is what we need to find: normal reaction and tangential reaction at O. Okay, so On, then we will have okay, So you'll have the weight of the rod acting downward, and then you'll have the weight of the sphere acting downward. Okay, if the rod is acting downward and the sphere is acting downward, okay, so we need to find out that what is the component of their weights in the normal direction. What will be the component of their weight in the normal directions? Okay, so now we need to determine that what is the angle here. Okay, if we draw the tangential direction, so what is the angle between the weight and the tangential direction? So this will be 45 degree. Now, how this will be 45 degree? This is not dynamics, this is mathematics. Okay, you can do this by understanding of the geometry itself. Okay, I do this like this, that since we have this line and this line making 45 degree, so perpendicular to these two lines will also make 45 degree. Okay, so perpendicular to this line is this is the tangential direction. Okay, and perpendicular to this line is this is this is the vertical direction. So this will also be 45 degree if this is 45 degree. But again, this is just the geometry. Okay, so you can understand the geometry in whatever way you want. Okay, this is my way of understanding. Two lines making an angle, the perpendicular of both the two lines will also make the same angle. So anyways, this angle will be 45 degree. Okay, so uh, so component of the weight in the normal direction will be in the negative normal direction, obviously. So it will be negative 10 into 9.81 sine 45, negative 15 into 9.81 sine 45. Okay, so these are the forces, because you'll have a component of weight here, component of weight here as well. This thing is equals to MAGN. Okay, so mass, now there are two masses, so you're gonna do summation of them. Okay, so mass here 10 into AGN is basically what? Omega square R. Okay, omega is provided, so omega would be the same, because it's the same angular this is the same angular velocity for the whole pendulum, whether it is the sphere or for the rod. So omega square will remain the same, but what will be R? R for the case of rod, it will be from the center of rod to this point of rotation. Okay, so that will be, since this hole is 600 millimeter, so that will be 0.3. And here it will be from center of a sphere to the point of rotation, so it will be 600 plus 100, 700, so like 0.7. So anyways, will be the first equation for summation of forces in the normal direction. Before moving further, do you understand how do we make this equation or not? Is there anything that you do not understand? How did we make this equation? Please ask. The last step. Last step means this one. Okay. So this is basically what? MAGN. So what is the formula of AGN? Uh, AGN formula is omega square R. You remember in chapter number 16, we studied that if we know what is the angular velocity, we can find what is the normal acceleration, and that's omega square R. So omega is given in the question. This will be the same omega, because this is the omega for the pendulum. So it will be the same omega for sphere and same omega for the rod. So it will be 3 square, 3 square. Now let's talk about R. R will be the center of the rod or the center of the sphere, from the center of the rod to the point of rotation, or the center of the sphere to the point of rotation. So center of the rod will be 300, so it will be 0.3, and center of this sphere will be 600 plus 100, that will be 700, so it will be 0.7. Uh, is this thing clear or not? So anybody who think that anything within this till here it's not clear, you can ask. Okay. Presumably it is clear to everybody. Let's move ahead. Okay, so we get on the normal component of the reaction. Okay, so now let's find out tangential component of the reaction. So summation ft. Okay, so it will be like ot plus okay, so we'll have weight. Okay, so weight is here, so but we need to find the component of the weight in the tangential direction, and it will be in the positive tangential direction. So it will be 10 9.81 cos 45 plus 15 into 9.81 cos 45 plus ot is equals to now MAGT. Okay, so mass, but we don't know we don't know what is AGT. So let's say AGT will be basically what? It will be alpha into T. Okay, so it will be alpha into R. So R would remain the same for the case of the rod as well as for the case of the sphere, but alpha is the angular acceleration, we don't know. So we can write here 10 into alpha into zero point 0.3 plus 15 into alpha into zero point 0.7. So now this is equation where OT is a function of alpha. Still, we do not know what is OT. Okay, so at this point, I'm going to stop here. I'm going to ask you, do you understand how did we make this equation or not? Is there anything within this equation till this step which is not clear? Please ask. The right side, the right side, you mean this one? Okay, this is basically what? MAGT, okay? Or you can say MAT. Okay, what is AT? At tangential acceleration. In chapter number 16, we studied tangential acceleration is R into alpha. Okay, that's the angular acceleration. So R will be the same for the case of rod, for the case of sphere. Alpha is something that we need to find out. And this is the mass. Is it clear? Anybody else who think any step is not clear, you can ask. Okay, the problem is still not solved yet. Okay, so because we need to find out what is the normal reactions. So what are the reactions? So we found ON, but still OT is not known because we need alpha. If we have alpha, then we can find what is OT. Okay, so what are we going to do is that we can take the moment, summation of moment at O. We can take the summation of moments at O. So summation of moments at O will be what? Summation of moment at O, it will be equals to I naught alpha. It will not be zero this time. Remember, this whole thing is actually rotating. So there is rotation. So summation of moments at O will not be zero. It will be I naught alpha. Okay. So let's talk about the moments. Okay. So what are the moments that we are going to have? Okay. So we'll have weight. So weight of the rod, component of that in the tangential direction will have a moment at O. Similarly, weight of the sphere, component of it in the tangential direction will have a moment. And then you remember we had an external moment applied as well, 50 Newton meter. So these are the three things which are going to cause the moment. Okay, so we'll have negative 10 into 9.81 cos 45 into zero point 0.3, negative 15 into 9.81 into cos 45 into zero point 0.7, negative 50. This thing is equals to I naught alpha. Before moving forward, do you understand this step or not? Is there anyone who do not understand this step? Please ask. Why 50? Because why 50 negative? Well, look, we are saying that clockwise is considered as positive. So everything is counterclockwise. the component of weight of the rod, or the component of the weight of the sphere, or this external moment. Look here, the external moment. This is also acting in the counterclockwise direction. Everything is working in the counterclockwise direction. We are assuming that positive is sorry, everything is working in the clockwise direction. We are assuming counterclockwise positive. So that's why everything is negative. It's based upon our assumption only. Okay. Um, this is a very good question actually that you asked. Because suppose if I give the same problem in the exam, suppose if I give the same problem in the exam, but instead of doing like this, I do like this. So what's going to change? Solution would remain exactly the same. Only one thing is going to change, that when you are doing here, instead of putting minus 50, you're going to put plus 50. Exactly. So anyways, so we took the moment. Still we didn't get alpha. Still we didn't get angular acceleration. Why? Because we don't know I naught. So now so now we need to find what is I naught. I naught is the second moment of inertia at point O. Okay, so how do we find this? So we have a rod, we have a pendulum. Okay, so what we do is that we find IO for the rod by using the parallel axis theorem, and for the pendulum, and for the sphere. Okay, so but eventually the IG for the rod should be provided, and IG for the sphere should be provided in the exam. So maybe that sheet in chapter number 17, in the beginning of chapter number 17, where you have the IG values for the rod, for the sphere, so that will be provided to you. So from there you can just take it out, that okay, what is IG for the case of rod, and then what is IG for the case of the sphere. Okay, and once you have the IG for the case of the rod and for the case of the sphere, plus M, which is the mass of rod, mass of the sphere, multiplied by d squared. Now d will be what? D will be the center of the rod to the center of rotation, or to the point O, or similarly the center of the sphere to the point O. Center of the rod to the point O is actually zero point 0.3, and center of the sphere to point O is actually zero point 0.7. Okay, so we just substitute all the values. You're going to get I naught. Once you have got I naught, then you substitute I naught here. You're going to get alpha. Once you have alpha, you substitute alpha here. You're going to get OT. Once you have OT, then you're going to use OT and ON to find out what is the overall magnitude of the reaction force. So actually this problem is done. Is there anything within the solution of the problem which is not clear? Please ask. This was actually a little lengthy problem. So if everything is clear to everybody, then let's move over next. Okay, this is the self-study problem. Cover if time allows. Actually, time does allow. If it in the exam, what would be the grade of it? At least 10 marks. If it's in the exam, then this question would be 10 marks, because there's so many steps in it. Will take at least half an hour to 40 minutes to solve. Okay, then we have some topic. This is topic for the general plane motion. We placed it like this: cover if time allows. So actually, we are moving very, very fast. In reality, chapter number 17 is finished today. This part we normally leave, but I'm not sure whether if Dr. Salim is going to cover it, then I'm going to cover it. If he's not going to cover it, then I can leave, because it's if I cover it, then it can come in the exam, this part. But it is a quite complicated part in the sense that your and you have rectilinear motion, which could be curvilinear, all which could be curvilinear translation or rectilinear translation. That motion along with the rotation together, that makes up the general plane motion. So the problems for the general plane motion are comparatively quite more complicated than the regular problems. So anyways, let's leave this part here. We cover, if time allows. We will not cover it right now. But I'm gonna see if Dr. Salim is gonna cover it. Then we are gonna cover it. Otherwise, we're gonna leave it. So with this, our chapter number 17 is finished. Actually, chapter number 18 is just 1 week. So next week, our course for dynamics would be finished in reality. Um, the reason why we finished a bit earlier, because normally in the first week we don't have lecture, but we started regular lecture in the first week, and then in the week when we had the exam also, we didn't take a break in that week. So we moved without a break. So that's why we are actually quite a bit early. So next week your course of dynamics in reality will be over. Okay, I'm going to confirm with Dr. Salim if he will be covering some additional part, then we're going to cover that as well. Otherwise, it will be all done. Uh, Student is asking, can we have a break now? Actually, not the break. Right now, we are going to finish our lecture today because we are done with chapter number 17. Next week, we are going to do chapter number 18. So anybody want to ask anything, you can ask. What is the material that will be included in mid 2? Oh, when is your mid 2 coming? I forgot that actually. Week 13. This is week number 11. So you have 2 weeks, okay? Okay. I'm gonna confirm with Dr. Salim, and then I'm gonna inform you. Most probably, I will emphasize that we did chapter number 12 and 13 in the first exam. We make chapter 14 and 15 in the second exam. So can you try to not include 16? Okay, okay. I'm gonna ask him that we include only 14 and 15, not 16 in the second exam. Okay. So, but I'm gonna confirm you. Okay. So just remind me, and that's it for today. If anybody want to ask anything, you can ask. Okay. Thank you. Inshallah, see you next week.